Hello and welcome to the second part of the tutorial on how to create volumetric light in Blender. My name is Paolo Ciccone and this is the Blender Survival Guide episode 12. Alright, this is where we stopped last time. We created this panel that we are going to use to shine some light into our room. So everything is fairly good. Let me just go back to edit mode, and I think some of these circles are a little too large, so I'm gonna just resize them a little bit like this. Okay, and this panel is good, but I want to create 3 or 4 of them because this is going to be covering a large window and I want to have more than one series of openings. So again, we're going to use our friend, the array modifier right here. And I think I'm going to start with 3 at least. Okay, so here is our panel, and if I turn on the manipulator, we see that the center of the panel is still in the origin of one of the holes before it was moved, and I don't like it that way. So I like to have the center of the object at the center of the object. Now ideally it will be here, but because this is an array modifier, the center will start from the center of the originating object, and that's good enough for now. So to create the new center, we stay in our editing buttons and we look at this series of buttons here and we click on center new. This should be new. Let me see if it works by rearranging things a little bit. There you go. Center new. And watch this area here. Okay, we're going to click it. And now we see the center of the object being moved in the right place. Okay, now we were developing this in a second layer. We have the rest of the scene in the first layer. Let me turn on both layers, shift click, and now we see that this object is way big, too big. So we're gonna resize it, press S, move the mouse down, and I'm gonna zoom in a little bit. Okay, let's move it in place first, size it again. Okay, I'm gonna use the height as a reference point, and we see that the ratio between these two objects, the window and the grate, as we call it, is not the same. So what I can do simply is to turn everything into wireframe mode. I press Z, then I right click on my room object here, and then go to edit mode, and the window is still highlighted, it's still selected. This is the last selection we had when we closed edit mode before, so we can simply accept the selection. We don't need to do anything else. We are gonna press S for scaling, and I'm gonna use X to scale the window in the horizontal direction, about like this. And press tab and click back on my object, reposition it, and down a little bit. It looks good. It looks, well, out of place there. So, okay, we're gonna just move it right here. Another proof that you have to really look at your scene from multiple points of view. And it's looking good. Maybe let's scale it up a little bit, just a little bit. It doesn't matter that it's not perfectly aligned with the window. This is not supposed to be symmetrical. So let's verify our position. I'm gonna move it here. Good enough. Okay, so next step, let's shine some light in the scene. Ha ha. So here it is. Our light is here. We're gonna turn this light into a spot. If you remember the old, our reference point, the scene from Serenity, it's clear that there are some sort of artificial light sources behind the window, behind the panel. So we're going to turn this into a suitable spotlight. We click on our materials, the light subpane is selected. This is called a lamp right now, which means it's an omnidirectional light, kind of like a light bulb, a naked light bulb. We want to turn this into a spot, okay? And we're gonna move the spot in position, down and rotate it. Let's take a look from the top, okay? And this spot is way large, too large. So we're gonna change the angle of the cone here. 75 degrees, way too much. Let's go at 35. And maybe we're gonna go even lower than that. And let's start positioning this in the right place. And it's definitely too much. Let's see what we can do with 25. And here, it's looking pretty good. Okay, so let's see, our cone of light, as we see here, is not really hitting the right spot. We're gonna move it like this. And let's see our monkey head here. Well, we can turn Suzanne a little bit in our direction and maybe can move it. Okay, so it's not right there in the corner. It's kind of like weird position there. And my camera here, it can be okay. I think it's just a little bit, I don't know. It's a little too narrow point of view. I want to get a little more dramatic, and I'm gonna change the camera lens to something a little more wide angle. So we're gonna click on the editing buttons with the camera selected, and we see that there is the default of 35 millimeters, which is an okay default. We're gonna lower this to 25, so we see more of the room, okay? And this monkey head, it's very faceted. Now, objects like this tend to be smooth in real life. So I'm gonna click here in our editing buttons. I'm gonna click on Set Smooth. All right, so that looks a little better. A little better. Not much better, but a little better. Okay, so now if we were to do a test render in Blender of this, this is pretty much what we get. There is no indirect lighting in Blender. Only the light that is shined through those holes in the panel is visible in the scene. And this looks pretty disappointing, isn't it? One thing that I probably didn't mention in the previous episode, though, is that we are not going to use Blender's built-in render. Let me repeat that. What we see here, the built-in render of Blender, is not what we're going to use. I know this is a little bit of a new concept, but thinking this way, a 3D modeling application not necessarily includes a render. There are programs out there that just model. They don't have any way of showing you the final picture. Blender's built-in render engine is actually rather good, but it's just one of the options that are available. There is another way of rendering images, and this is through an external rendering engine, and the capabilities of that rendering engine are going to drive the final result. Now, relax. All this is very easy. The first thing that is important to know is that I'm not going to use another commercial product. What we're going to see is a rendering engine that is, again, open source, so it's available to you for no cost. You can download it today, and it's available for Linux, Windows, and Mac OS. So anybody can use it. This wonderful render engine is called Lux Render. And Lux Render is a different rendering engine, because the vast majority of rendering engines, like Pixar's RenderMan or any other render engine that is built in the application, like the one in Blender or Cinema 4D or Maya, all these renderers are generally not rooted in reality. They simulate a portion of the behavior of light, but then they have to cut corners, otherwise the rendering will take forever. LuxRender is different. It's a physically based renderer. And what that means is that Lux is actually simulating through extensive mathematical models the behavior of light. So if the light goes through a piece of glass, there is an absorption. Basically, the amount of light that comes out from the other side of the glass is not the same that entered the glass. The glass will retain part of the photons. There is a refraction. There is all kind of effects, caustics that are projected on nearby surfaces. This image here was all created in Blender and Lux. There are other images you can see in the gallery, and they are astounding. I mean, they are just amazing, amazing images. And many of these images are created with a very few lights, because Lux can actually use one light and make it behave exactly the way it behaves in reality. So if you are a photographer, for example, you have photographic background, or you are familiar with the way light works in real life, then Lux will be very easy for you to use because it mimics real life. Now you can install Lux. Let me show you where it is. And the URL is luxrender.net. It's an open source program. I would suggest at this date, beginning of May 2010, we have the version 0.7 RC2. What that means is the version is 0.7. They're very modest, the developers. They don't think they reached a point where this is worth of being called 1.0. I disagree with that. The program is amazing. But that's okay. It's typical modesty of the open source world. And RC2 means Release Candidate 2, which is another way of saying Beta 2. The program is very stable. Use it. It's very, very well done. Install the version linked here. There is, again, a Linux, Windows, and Macintosh OS version available. And the Mac OS version runs on 32 and 64 bits, which is amazing. Now, when you have Lux installed, then you can go back to Blender. Of course, you will need to exit Blender, install Lux, and then restart Blender. So once you have it installed correctly, if you look in the render menu of Blender, you should find this option, Lux Blend 0.7 RC2 Exporter. What that means is this. Lux is an external program. It's a totally standalone program. It does one thing and one thing only, and it does that thing very well. It only renders 3D scenes. Now, Lux doesn't read the blend file directly. Lux is designed to work with a wide set of external applications. You can use Lux with Blender, you can use Lux with Maya, you can use Lux with Cinema 4D, you can use Lux with many other applications. The only thing that you need is an exporter, basically something that takes this scene, in this case, exports the scene in external file using the Lux render file format, and then you run Lux against that scene. Now, all this is done automatically for you in a wonderful way by the Lux render exporter, which is built in, it's included with the installation of Lux render. So once you have installed the application correctly, it will appear here. It's a Python program, so it will run on any installation of Blender 2.49. And when you run it, it will ask you if you want to set the path to the Lux render software. This is happening the very first time. Even though you installed the program and everything went well, the LuxBlend program, the plugin here, doesn't know automatically where the Lux Blender program is. So the very first time you have to set the path. And let's take a look at how it's done. I say yes, and I can navigate to my applications folder. In this case, this is under macOS. And Lux, in this case, is under Lux Render. I don't need to click on the application. I just need to set the path of the directory. So we don't need that. With this path, in this case, and on Windows will be different, but you know where it is. I click Select File. And now I have my LuxBlend interface. The LuxBlend exporter relies on materials defined inside Blender. So before we can go here, we have to assign materials to our scene. So let's start with good old Suzanne. Right-click on the monkey head. We go to our materials. There is nothing here. So we add a new material, and we call this monkey. Now, we don't care about the rest of the material. We are not going to use Blender to define the material. We're going to use Lux. And in fact, you just noticed that something happened here. Basically, when you use Lux Render, you define the material in Lux, not in Blender. You just define the existence of a material. So for example, here, I'm going to right-click on the building, and I'm going to add a new material and call this walls. Okay? So this is done. This is done. Let's right-click on the monkey. We go here. Lux defines materials not as a series of arbitrary properties as we do in any other modeling and rendering program, but in Lux, because it reproduces reality, the materials are rooted in reality. And what that means is the way glass reacts is different from the way metal reacts, or the way a matte material reacts. So first of all, let's take a quick tour of our interface. You see that there is an orange bar highlighting material. This is where we are now. Consider these a series of tabs. So we have a material, camera, environment, render, output, and system. All right. If we are in material, when we have an object highlighted, selected inside Blender, then we can see the corresponding configuration in Lux. And so here we see that material, the current material, is in fact monkey. This is the same material that we have defined here. Material type indicates what kind of material is this inside Lux. By default, Lux looks at the properties of the material, tries to guess. It guessed glossy. Well, let's pretend that this large monkey head is made of some shiny material, some metal. Here it is. So we can select metal, and in the name we can select, for example, aluminum. Seems so non-glamorous, but this is okay. This is good enough. So now I'll right-click on the wall, and I switch back to Lux, and I see that the material has been switched to walls, and it says glossy. Well, normally my walls are not glossy. They are matte. Okay. And I can change the diffuse color of the matte material to be, I don't know, and some sort of off-white here. Maybe something like this. Okay. Now, what about this light? If I right-click on this, the light is also converted. And in fact, we see in the Material tab that the spotlight is a spotlight. It has a color temperature of 6500 Kelvin, which is pretty interesting. You are not just changing the color of the light, but in Lux you can actually map this light to be exactly at a given color temperature. That is what cinematographers do on a movie set. Let's leave the default for now. Before we render this scene, let's take a look at the System tab. And this is basically my default output there. Users, name of my account, desktop. So the program will generate a bitmap in my desktop. What kind of bitmap are we gonna use? Well, that is determined in the Output tab. And here I have my resolution, 1280 by 720. This is my default. I don't want to use this high resolution initially to create some test renders. It will take too long. So I can lower again, as we do in Blender, I can lower the output of my render frame to 50% of the size. Forget about all this stuff for now. But here I can select if I want an OpenEXR output or a ping output, and I'm going to use ping for now. And this is the default. There is nothing to do. We could select Targa. No problem. Leave all this stuff alone. Once everything is set correctly, then you can click on Render. And that will automatically export the entire scene to a separate file, and it will launch Lux. And right now, seems like nothing happened. It did happen. It's just that the program is in the background. So here it is. You just need to switch to it. And oh, Lux, unlike other programs, other renderers, doesn't render the scene from line 1 scanning down. It renders the entire scene in one single operation, and then it keeps refining that solution until you stop it. You heard me right. The program will basically never stop until you click on the stop button. It will continuously try to refine the image, making it better and better and better. But here is an immediate result. We see that instead of having some spots of light like we had in Blender and everything dark, there is a reflection. Look at this highlight here. And look how the light is reflecting on the ceiling. This is all that happens because the light is shining on a very reflective surface. This is aluminum, and then bouncing off from the walls and creating this indirect lighting. Here you have a series of panels. There is an HDR histogram. We're going to just close that. And you can see in this case that Lux is using 16 threads at the same time. I'm working on an 8-core machine using hyper-threading, and so Lux takes advantage of the entire hardware available. This is like a mini render farm in a box. You can decide to lower this, so if you want to keep some CPUs available for other tasks. But anyway, this is looking rather good. I don't want to have this kind of a highlight right there on Suzanne's face, so we're going to need to move the light. But this is a rather good start. So we can just close Lux. We're back to our scene. So let's see. I can just take my light here and rotate it a little bit. And maybe I can move Suzanne in this direction a little bit. Let's see what happens. Render. Switch back. And we can see the beginning of the image forming. And here is an interesting measurement. You can see it's at the bottom of the UI. We can see this over px. That means samples per pixel. And this is a measurement of the fidelity of the image. So samples per pixel is actually a good number to keep in mind. As a rule, I think that in general, depending on the complexity of the image, depending on the size of the image, but anywhere between 450, 750 samples per pixel, that is what you want to get to create a good image. And so you see now that Lux is refining and taking more and more samples per pixel. That means basically each pixel is analyzed to see the effect of the light bouncing off different surfaces, creating all kinds of highlights or going through glass. One thing that is worth mentioning is that we can stop this, and if we go to Suzanne and in the material tab we decide that we want to change the material to be glass, then we can select a preset and say, well, I want glass at 29% lead or anything. You can change all kind of different presets, and this is changing basically the index of refraction of the glass. Let's leave the preset for now, and now I can re-render, and at this point we should see quite a dramatic change in Suzanne's appearance. Not only the material will be different, but the way light goes through the material and generates all kinds of reflections in the environment. That is quite amazing. And we can already see some of those effects of caustics in the scene. And now you see how easy it is to change materials inside Lux. But as impressive as this is, we still don't have the volumetric light. Don't worry, I didn't forget. It's just that this video is already going for quite a long time, and it's time to take a break. So I'm gonna stop here and conclude, this time for real, I promise, conclude this tutorial about volumetric light in the next video. See you soon.